This program comprises Unit number 7, Data Communication and Networking. After the completion of this unit, you will be able to learn the conceptual model and basic elements of data communication system, differentiate between data transmission mode and data transmission forms, understand different types of data transmission media, know about basic concepts of computer networks, have a knowledge of switching and routing techniques, understand concepts of OSI layer model. Data communication. Data communication is the flow of electronic data among two nodes, computers and other devices, through communication media. To manage the communication, the nodes must be part of communication system and linked with each other. Furthermore, the data communication software is used to transfer data from one node to another. The communication system is governed by three fundamental principles that include deliver, accuracy, and timeliness. Number 1. Delivery. The system must carry data to the correct destination and data must be received by the correct recipient. Number 2. Accuracy. The system must deliver the data with accuracy. The incomplete data is unusable. Therefore, it should be accurate as per sending format. Number 3. Timeliness. The system must deliver data in time. Late delivery of data may not be effective. Therefore, timely delivery should be achieved. Basic elements of communication system. Following are the 5 basic elements required for any communication system. Number 1. Message. Message is text, audio, video, and images that is communicated over the communication system. Number 2. Sender. The node that is used for transferring messages is called transmitter, source, or sender. Number 3. Medium. Medium is the pathway through which message is sent from one point to another. Wire, telephone lines, fiber optics, or microwaves are mediums used in these days. Number 4. Receiver. The node that receives the message is called the receiver. Number 5. Protocols. A protocol is a set of rules. A protocol is a set of rules which govern the data transmission between sender and receiver. Without protocol, the information is useless for the receiver as a person understanding only Urdu cannot understand English messages. Therefore, messages sent over through communication protocols can only be understood by the receiver. Data representation forms. Different kind of information can be sent over through a communication channel. It includes the following. Number 1. Text and numbers. Text and numbers are sequence of bits, zeros or ones. They are represented by a set of bit patterns typed using the keyboard and is called a code. Number 2. Images. Images are also characterized by special bit patterns. It is comprised matrix of pixels, picture elements. The size of image is larger than that of text and numbers. Therefore, data transmission speed is important for reliable and fast delivery of images. Number 3. Audio and video. Audio and video refers to the recording or broadcasting of music or sound and video or movies. They are also sent over the communication system. Types of network. A computer network connects two or more systems in order to exchange data and information with each other. Computer networks are classified into 3 broad categories, that is LAN, LAN, MAN, MAN, and WAN, WAN. Local Area Network or LAN. A local area network connects group of computers and devices with each other within a limited geographical area. Each node in a LAN has its own CPU and storage area. In addition, it has the access to the resources of other nodes available in LAN. It allows the users to share hardware and software resources in LAN. They can also communicate with each other by sending messages and emails. LANs are characterized by the following properties. Number 1, they transfer data with a very high speed. Number 2, they exist in a small geographical area. Number 3, the LAN technology is less expensive. Metropolitan Area Network, or MAN. A MAN, Metropolitan Area Network, is a larger network than LAN, comprising of a large city or area. It can connect several nearby LANs to one another and individual systems at high speeds. Wide Area Network, WAN. A wide area network, or WAN, interconnects LANs and MANs. A WAN may be located within country or it may be interconnected the whole world. They can span in an unrestricted geographical area. They are more complicated and complex than LANs and MANs. The WAN technology is expensive. Network topologies. Network topology is the connection arrangement of nodes in a computer network. It is the topological structure of a network that defines configuration of cables, computers, and other peripherals. The major types of network topologies include star, ring, bus, and hybrid topologies. Star topology. Star topology is the most general type of network arrangement that is used in offices and homes. In star topology, all the computers are connected to a central hub or switch. The communications take place via hub, which acts as a common connection device. All the data initiated by nodes pass through the hub. The hub forwards it to the destination node. Hub also manages and controls the whole network. Advantages of a star topology. Number 1. The star topology is easy to install. Number 2. The wiring arrangement is also easy. Number 3. The transmission delays do not increase if a new node is added. Number 4. If any node fails, it does not affect the network. Number 5. It is easy to detect faults. Number 6. Addition and removal of parts is easy in star topology. Disadvantages of a star topology. Number 1. Star topology requires large cable length. Number 2. If the hub goes down, the whole network will be blocked. Ring topology. The computers are attached with each other in a closed cable. Each node has exactly 2 neighbors. The computers and devices connect each other and complete the network. Data passes through all nodes until it reaches its final destination. Any breaks in the connection loop might take down the entire network. Advantages of a ring topology. Number 1. There is no central device for controlling the network. Number 2. Ring topology is easy to install. Number 3. The wiring arrangement is also easy. Number 4. It provides equal access to devices and not a single node uses all the bandwidth. Number 5. It is easy to detect faults. Number 6. Adding and removing nodes is also simple. Disadvantages of a ring topology. Number 1. The transmission signals goes in sequential order which creates delays. Number 2. A single break in cable can disturb the flow of the whole network. Bus topology. Bus topology is one of the most simple network topology. In bus topology, all the nodes are connected into a single cable. This cable is the backbone of the network and therefore it is known as the bus. Every node sends and receives data through this bus. Advantages of a linear bus topology. Number 1. It is easy to add a new node in bus topology. Number 2, bus topology requires smaller cable length as compared to star topology. Number 3, it is also cheaper as compared to star topology. Number 4, it is suitable for smaller networks. Disadvantages of a bus topology. If the main cable breaks, the whole communication system goes down. Number 2, all nodes should be capable of responding immediately against messages. Number 3, the main cable requires terminators at both ends. Number 4, if the number of devices is increased, it drops down the efficiency of bus network. Number 5, it is not appropriate for networks with heavy amount of traffic. Number 6, the security of bus network is low because all the nodes receive the signals from the source. Mesh topology. A mesh topology is made up of a network where each node is interconnected with each other. It provides a one-to-one connection amongst all the computers on the network. The arrangement of mesh technology is very expensive as dedicated connections are required between every node of the network, and it results in many redundant connections. The mesh topology is not frequently used to develop media-based computer networks. Advantages of mesh topology. Number 1. Mesh topology allows to send data from different devices simultaneously. Number 2. If one of the nodes fails, it does not affect the network. Number 3. Extension and alteration in mesh topology can be done without disturbing the other nodes. Disadvantages of mesh topology. Number 1. There are high chances of redundancy in many of the network connections. Number 2. Overall cost of mesh network is high as compared to other topologies. Number 3. Setup and maintenance of this topology is also very difficult. Data transmission modes. There are 3 modes of data communication: simplex, half duplex, or full duplex. Simplex mode. In a simplex connection, the data flows only in one direction, from the source to the destination. For example, in television and radio transmission, data and message is transmitted from the radio television station to the radio and television set. Half duplex. In half duplex, the data flows in both directions, but one at the same time. It means that message can be transmitting at one time, not received. Walkie-talkie is an example of half duplex where a user ends his transmission with announcements of over to prevent overlap and facilitate the other one who's talking. Full duplex. In full duplex, the data flows in both directions at the same time. Each node can thus transmit and receive the data simultaneously. Telephones are common examples of full duplex devices. They allow both users to hear each other and talk at the same time. Data transmission speed. Data transmission speed is measured in bandwidth. It is a measure of the amount of data transfer through a network over a given amount of time. It is also called data transfer rate or baud, or expressed in bits per second, BPS. Data transmission forms. There are 2 forms of data transmission, that is, analog and digital. Analog transmission. Analog is the transmission of data in a continuous waveform. The human voice is an example of analog data. When someone talks, an analog wave is created in the air medium. Analog signals are represented by continuous range of values as shown in the following figure. Digital transmission. Digital is the transmission of data using distinct on and off electrical states. As you can switch on or off your light, the data bit can have values like 0 or 1. The combination of these bits forms the digital data. Digital data can be converted into analog signal which is then transferred from one computer to the other. At the receiving end, it is again converted into digital signal. Data transmission media. Data transmission media is the pathway used to carry a communication signal from one node to another. There are two types of transmission media. Guided media. Guided transmission media is based on a cabling mechanism that directs the data signals along a specific path. The data signals are dependent upon the physical characteristics of the medium. Therefore, it is also called bound media. There are three basic types of guided media. Number 1, twisted pair. Coaxial cable. Number 3, optical fiber. Twisted pair wire. Twisted pair is a couple of copper wires twisted together and enfolded with a plastic coating. Each pair consists of two wires used for the positive data signal and negative data signal, meaning ground. There are two kinds of twisted pair wire. Number 1, shielded twisted pair. Number 2, unshielded twisted pair. Shielded twisted pair, or STP. Shielded twisted pair cable is composed of two cables, twisted with each other and enclosed in a foil cover and copper shielding. STP cable uses shields to reduce outside interference or noise. It is a more secure cable since it keeps the signal from leaking out of it. Unshielded twisted pair, or UTP. Unshielded twisted pair cable is not enclosed in copper shielding. UTP cable is usually very flexible and is easy to use. However, it can get unnecessary interference and data from other cables and networks. The other disadvantage is that the UTP, while traveling through it, may leak to other nearby cables. UTP cables are used in local telephone communications and short distances up to 1 kilometer. Coaxial cable. Coaxial cable, unlike twisted pair, comprises of one conductor. It consists of one copper wire which is covered with a shield. Coaxial cable can be used over longer distances and supports more stations on a common line than the twisted pair. Coaxial cable is one of the most common types of flexible transmission medium. Due to its flexibility, it is used in wide variety of data transmission applications. The most important of these include television network, long-distance telephone communication, local area networks. Optical fibers. An optical fiber is a slim, flexible, and thin glass fiber medium for data transmission. The optical fiber transmits data in the form of light signals. Electrical signal converted in light and at receiving end, light signals are reconverted into electrical signals. The shape of optical fiber is like a cylinder that consists of three sections: the core, cladding, and the jacket. Some important features of optical fiber include the following. Number 1. Optical fiber provides protection against external electromagnetic fields. Number 2. Optical fiber has low attenuation than coaxial cable or twisted pair. Number 3. They are smaller in size and lighter in weight. Number 4. They have greater capacity of data transmission. Uses of optical fibers include the following. Number 1. Optical fibers are used as light guides and imaging tools for microscopic study and factory automations. Number 2. Optical fibers are used as lasers for surgeries in medical field. Number 3. Optical fibers are used to construct networks of different topologies. Number 4. Optical fibers provide high-speed data transmission with accuracy. Number 5. Broadcast cable companies are using fiber optic cables for wiring purposes. Unguided media. Unguided media doesn't use any physical path between the two devices communicating. It simply carries electromagnetic waves without using any physical medium. Signals are normally broadcast through the air and carry on to the receiving end. Important types of unguided media include microwave systems and communication satellite. Microwave systems. Microwaves are of high-frequency radio signals that transmit data through space. It is used to provide communication link among long-distance areas. Following are the types of microwaves: terrestrial microwaves, satellite microwaves. Terrestrial microwaves. Terrestrial microwaves are used to broadcast wireless signals across a short distance. The transmitter is a parabolic dish and is mounted at height to get the best frequency and transmission. These waves cannot bend or pass through buildings and hills, therefore unblocked line of sight must be available between the source and the receiver. Repeaters are also used at a distance of 25 to 30 kilometers between transmitting and receiving stations. Both private networks and common carriers can use terrestrial microwaves. Terrestrial microwaves are used for both audio and television transmission. Satellite microwaves. Satellites are transponders that are set in orbits directly over the equator. Communication satellites are microwave relay stations placed in space. Satellite dishes are used to send the signals to the satellite, where it is again sent back down to the receiver satellite. The uplink is the transition of data from Earth to the satellite. The downlink is the receiving of data transmitted by the satellite. The communication satellite is a technological revolution in modern data communication. They are used in different data communication applications like number 1, television distribution, number 2, long-distance telephone communication, number 3, private commercial networks. Because of their broadcast nature, satellites are used to broadcast live news and TV broadcasting to the world. Satellite communication also provides one-to-one link between telephone exchange networks. It provides an efficient and reliable way to connect international trunks. Now, mostly data communication is performed using fiber optic and satellite. Switching techniques. In a network, one-to-one node communication requires some complex arrangements. It is not possible to connect each node to the other with a separate cable. A better solution is switching. A switch is a connecting device that links network devices. Switches are also capable of building provisional connections between two or more network nodes. There are two important methods of switching, that is, circuit switching and packet switching. Circuit switching. In circuit switching, a devoted circuit is built during transmission of data. In this method, a physical path is created for a single connection between two endpoints in the network for the period of connection. After the circuit has been established, the data transfer takes place. The transmission path is booked during the transfer of data, and other systems cannot use it until the data transfer is completed and the circuit is released. The most common example of a circuit switch network is the public telephone network like PTCL, which provides telephone services. Advantages of circuit switching. The circuit switching communication is efficient. There are fewer chances of errors. It is also highly reliable. Disadvantages. Circuit switching requires a lot of formalities during formation of the circuit. The bandwidth may be wasted, especially when a user is only listening and not talking. The setup of the channel may take up a longer time. Packet switching is another communication method which converts data into small size blocks called packets. The packets have different types of transmitting data regardless of content, type, or structure. Each packet contains a header, which consists of routing information from source to destination. The same data path is shared amongst the users in a network due to division of different data items into packets. The packets are also independent of each other and therefore dedicated communication link is not required. This type of communication between sender and receiver is also known as connectionless. The example of packet switching includes Internet, where most of the application transfer data via connectionless mode of communication. Advantages of packet switching. It makes efficient use of network resources. It can manage variable data rates. It can easily handle increased number of transactions. Disadvantage of packet switching. It is not a good scheme for small data packages. The ordering of packets may alter during the transmission and reordering requires time. Routing techniques. Routing is the process of transferring information from one location to another across a network. It is also referred to as the procedure of selecting a path to send the packets over a network. Routing is one of the most important features of the Internet because it takes messages from one node to another. Each node receives information and passes it to the other until it reaches its destination. A router is a device that carries route to the routing process. It receives the packet and forwards it to its next destination node. It is located at gateways, the network connection point, which connects two networks with each other. Source routing. Source routing is a technique that is used to specify the route of a packet through the network. In this routing technique, the source needs to pass information along a specified way. Therefore, the path through the network is set by the source node. Source routing can be used to troubleshoot a network and increase the network performance. Hop-by-hop routing. In hop-by-hop routing, the source does not have all the information about the destination. In this method, each node along the path passes the information packet only to the next node. The packet forwarding process keeps on working until the final destination is reached. Hop-by-hop routing decisions are based on channel availability and readiness of adjacent nodes. Difference between switching and routing. The switching method makes use of switches only. A switch acts as a connector only. It receives packets and sends them directly. It connects one point of a network to another, turning it on and off as necessary. A switch examines the MAC address and determines where a packet should be sent within the data link header of the packet, where the MAC address is unique identifier of network interface card. A switch maintains information about MAC address and related ports in database and uses it to find the next location. The routing method makes use of routers. A router acts as a connector and a scheduler and manages traffic of the network. It determines the optimal path in a network and routes packets accordingly. The router makes use of this routing to determine the route to the destination host. Communication protocol. A computer network connects two or more nodes together to share data, information, and resources. Multiple networks are connected together to form a grand network. Besides the cable, there are many processes that execute behind the scene in order to run the network smoothly. However, the smooth running of network is governed by some standards and specifications. These standards and specifications define set of rules for data communication and network. A protocol is a set of rules and procedures that governs a process. A communications protocol describes the rules and regulations for data transfer between nodes over a network. In a computer network, a communication protocol performs the following functions. Number 1, it defines the size of data packets. Number 2, it provides numbering scheme of data packets. Number 3, it provides error and flow control. Number 4, it also defines mechanism of connection establishment and termination. Number 5, it manages the data security. Number 6, it manages the data routing algorithms for delivery of data. Number 7, it also manages the communication log information. The most important network protocol is OSI. Concept of OSI model. The Open System Interconnection OSI is most commonly used protocol in network communication. The OSI model was first released in 1984 by the International Standards Organization or ISO. It describes the data transmission procedure in the form of 7 layers. It explains how information is sent through a sender to a receiver and also describes different stages where information takes different form through the underlying architecture of 7 layers. The OSI model consists of 7 layers, each corresponding to a specific network function. The 7 layers are physical, data link, network, transport, session, presentation, and application. Layer 1. Physical layer. Physical layer is concerned with the bit stream that is transmitted over the physical medium. It deals with electrical, mechanical, and timing specification of the interface and transmission medium. It also defines the functional and procedural specifications of the medium. The physical layer is hardware specific and describes procedures and functions for dealing hardware over the network. It also deals with physical characteristics of medium, data rate, synchronization, and line configuration and physical topology of the network. Layer 2. Data link layer. The data link layer is responsible for transmission of data over the network. It receives messages from upper layers and assembles it into frames. Data link layer converts these frames into bits for transmission over the network. It also receives the bit at the other end and reconverts it into the frames. The data link layer has other functions as well, such as physical addressing, error, flow and access control for a single link between network nodes. Layer 3. Network layer. The network layer is responsible for delivery of messages from source to destination. It deals with routing of messages by translating logical addresses into physical addresses. It determines the path of the data on the basis of network environment, urgency of service, and other factors. It also manages traffic flow and associated problems on the network, such as switching, routing, and congestion of data. The network layer handles the routing and packet filtration using the logical addressing mechanism. Layer 4. Transport layer. The transport layer receives messages from session layers and divides it in the form of packets. It submits the packets to network layer for transmission over the network. At the receiving node, it resequences the messages by reassembling the packet segments. The transport layer ensures end-to-end delivery of packets and sequence and ensures error delivery without losses or duplications. The transport layer facilitates the upper bit, hiding the complexities of network operation from them. It also manages connection, flow and error control. It uses acknowledgements to manage source to destination flow control. Layer 5. Session layer. The session layer manages dialogues between two computers. It looks after identification of names and security parameters that are required by applications to communicate with each other. The session layer inserts checkpoints in the data flow to synchronize the data stream. The checkpoints break the data into smaller groups for error detection. The session layer also incorporates protocols to resume dialogues that have been interrupted. Layer 6. Presentation layer. The presentation layer looks after syntax, grammatical rules, and semantics of information needed for communication between two nodes. It defines the data and display format required to exchange information amongst network computers. The presentation layer also handles the data formatting details such as data encryption and data compression. Layer 7. Application layer. The application layer of the OSI reference model enables the user to access the network. It is concerned with providing user interfaces and services on the network like file services, print and email services, and database services. Network Interface Card. Network Interface Card is a hardware device that physically makes the connection between the computer and the network cable. It is a printed circuit board that is installed on the expansion slot of the computer. It also provides a port to connect the network cable. The important functions of NIC are to send the data to another host, to receive the incoming data and translate it into machine language, to prepare data from the computer for the network cable, to control the flow of data.